Alright, today we want to look at how we can answer this question on the board. We have been told that a car starts from rest and attains a velocity of 40 meters per second in 20 seconds. It maintains this velocity for 30 seconds and then comes to rest in 25 seconds. First of all, we have been asked to sketch the velocity time graph for the motion. And how can we do that? First of all, we take our vertical axis like this nicely against our horizontal. Okay, at the vertical we put our velocity there nicely, and the horizontal we put our time in seconds. All right, and this is meters per second, as we can see here with the velocity. And we have been told that the car starts from rest, and since the car starts from rest, our initial velocity is going to be 0. All right, so that will be 0 meters per second. So we should not forget with this starting from rest of a body. All right, so the origin here, this is where we are going to put our initial velocity. So let us look at the question again. A car starts from rest and attains a velocity of 40 meters per second. So we step here, then we go like this. Okay, and the car accelerates from the velocity here, which is 0, okay, with a maximum speed of 40 meters per second. So here we trace our maximum speed, which will be 40 meters per second in 20 seconds. So we drop it down to have our time, which will be what? 20 seconds. Now it continues and says that it maintains this velocity for 30 seconds, and this is what we call constant velocity or 0 acceleration. And with that we go horizontally like this. Okay, and the time for that constant velocity is 30 seconds. So we add our 30 to the 20 and we are going to have 50 here, so that all the time the difference between the two numbers will correspond to the time given for the constant velocity. And then comes to rest, and this is what we call deceleration, with a time of what? 25 seconds. We add our 25 to the 50 and we are going to have, that is 75 here, as we can see. So this will give us the sketch that we are looking for on the board. Okay, let us look at the II. The II, we are looking for what? Acceleration. All right, and we know that acceleration is equal to v minus u all over what? T. From the diagram, our v will be the final velocity, which will be 40. All right, 40 meters per second, and the u is the initial velocity, which will be 0 because the body starts from rest. And our time for the acceleration is going to be what? 20 seconds nicely. So we fix these values into the formula here. 40 minus 0 all over 20. So 40 divided by 20, and we are going to have 2 meters per second squared. So this is how we can get our initial acceleration here. Let us look at the total distance covered. All right, total distance covered. Now the total distance that we can see here is from the origin here up to the 75, and it covers a part where we can look at this diagram as a trapezium. Okay, so we say total distance covered is equal to the area covered by what? The trapezium. Or we can also find the area of this part, the area of this part, all right, and the area of this part, and add everything together. But the easy way is that we can say the total distance covered, all right, is equal to the area covered by the trapezium, or the area of the trapezium. Nicely we write it, and the formula is going to be 1 over 2 multiplying the summation of these two lines that are parallel. So let us put A here, all right, and from 0 to the 75 we can put b there, okay, so that we can have our formula nicely. So it will be a plus b times the height of the trapezium. So let's see how we can fix our values into this formula. Our a is the distance from here to here, which will correspond to the difference between the 50 and the 20, which is going to be 30. And also our b is from the 0 to the 75, and the distance there is going to be what? 75 times our what? Our height. That is from the origin to the top here, and we are going to get 40. Okay, nicely. So we proceed. As we add this, we have 105, all right, times 40, which will give us 2100 meters. So this is how we can answer this question nicely. Thank you.